Hey everyone, this is David D. Hilster. I'm from the CNPS, but a lot of you know I'm broadcasting live today to the CNPS, the Chappelle Natural Philosophy Society, which I am one of the directors and one of the people who make that society go. A society that supports people with different ideas, people who are thinking outside the mainstream, who are critical thinkers, as you can see. And I do want to welcome also my subscribers from Dissident Science, hit over 3,000 a little while back. I want to thank everybody for subscribing. And yes, I know I owe you guys a video, but my father and I have been working on our model in our book, as many people who are in the dissident area working on their work. But also, as we all know, if you are a dissident scientist, most likely you are not making a living at that, and you have to survive. And I have my own job as well, and I've been in crunch time for that. So, but I want to welcome everybody to this show today. We have an amazing show today, so don't go away. But if you have to go away, you can watch this. It is recorded. And I'm starting a new series here. For those of you who are not seeing Franklin, Franklin is here. Franklin and a lot of people have been keeping this channel going very strong, this show very strongly every Saturday morning. And I want to thank Franklin and his crew for really going out there and coming every day, every Saturday, and talking about really interesting topics and keeping the dissident critical thinking going. And they've talked about pretty much everything. But the series that I'm looking to do in the next coming weeks, I'm already lining up new other people who I'm going to be interviewing, including George Coyne, who has written a book and writing a second book on consciousness. It is great. I'm not really into that as much, but at our CNPS 2017 conference, in fact, he did come and give a talk on that, and I was quite impressed. So we're going to be talking about that. Also, I'm going to try to get him to talk about the Big Bang because he has 20 or some types of reasons why the Big Bang, in fact, is not correct. I also I'm looking forward. We're going to be talking to Stephen Bryant, who wrote the book Disrupting Physics, very modern book. And also, I'm looking to talk with my father about the particle model we're working on. And so the whole idea is looking at dissident science in the 21st century. I mean, my goodness, we're in 20 years already. We are 20% into the 21st century. What are the critical thinkers and people working outside the mainstream doing today? But today we have a super, super treat. And who we're going to be talking with is Jeff Yee, in my opinion, one of the really great, great young minds. One of the things is because I'm now 60 years old and I've been involved with dissidents since the early 1990s. I get asked and I get a lot of comments from the old timers in our group. Hey, Dave, there's no new blood coming in. It's like we're just seem to be dying off. All the dissidents of that have been working in the last numbers of years have, in fact, either leaving us, or we're just not getting new blood. That's not true. We're getting a lot of people via not only YouTube and Facebook, but people who are doing great work out there. A lot of times we find them or they find us. So I'd like to introduce you and bring up today's special guest, Jeff Yee. Jeff, welcome.
Hey, Dave.
So how's the breathing out there? Jeff lives in the Bay Area, and as we know, the West is ablaze. How you guys doing out there?
Much better now. The smoke seems to have cleared, at least temporarily. There's still fires going on, so we'll see which way the winds shift over the next week or so. But it's nice to see the sun.
Okay. Well, at least for now, hopefully in the next 2 hours, we won't get any evacuation from your side. But it is absolute joy to talk with you. I've been following your theory. In fact, I have done my best to help you out in the sense of getting the word about your work because I think it's really fantastic. If you haven't or don't know about his work, you can go to, let's see here, I've got it right here. Sorry. There you go. His energy wave theory, you can go. He has a website, extremely well put together, extremely professional. And not only that, he has a YouTube channel of the same name. Just look it up, Energy Wave Theory. You can get that, get to that by just Googling that or going to his website. And there you're going to find lots and lots of explanation and videos. But the reason I brought Jeff in today was because he is starting a project, but I think he's going to talk about his theory some, right, Jeff? Is that true?
Oh, but to the extent there are questions, I mean, I'm really hoping to announce the contest today and
Oh,
get into those details. But yeah, to the extent there are questions about the theory, I'll be happy to
okay,
answer.
gotcha. Super. All right. We want to make sure we got this what's going to be happening today correct. But I will talk just introduce that. Jeff is doing something. One of the things that I think the modern theories out there are doing. My father and I are working one. Jeff is working on one. Lionel Denou. And Laurie Gardy are working on another, an ether theory, and also there's another theory out there, the infinite universe theory. One thing that all those what I call more modern dissident theories have in common is that they are all pretty much based in the Newtonian world. Yours is based on the Newtonian world. Is that correct, Jeff?
Absolutely, yes.
Yeah, and I think that's one of the things that I love about these new theories because one of the problems I've seen a lot of times in our theories before in mainstream theory is you get things like magical charge where, I'll take this and put a plus on it and I'll take this and put a minus on it and they'll come together. And these new models are out that are out there. Movement comes in a Newtonian way. There's no magic out there. So that's one of the things I can put up front because we'll be talking at least to, I'm hoping 3 of those 4 models will be coming on. I know the new, they're not ready to come on yet, but I just want to give people that kind of heads up. So today's models don't include charge, right? Right, Jeff? You don't have charge in your model?
No, you have to explain charge. You're
Right,
absolutely right,
exactly.
but to get rid
Exactly.
of the unit of charge disappears, the Coulomb
Right.
charge.
Right. And one of the things I really, 2 things. One, his theory greatly simplifies the standard model. I mean, greatly. It goes from 19 to 28, depending on free variables or whatever you want to call them, to down to, I think, 4. And again, you can go to this website and take a look at it. But today, he's going to be talking about a project which is really fascinating, something I've actually thought of myself. I'm not kidding, Jeff. I'm not I'm a computer programmer. I know very much what Blender is. And I thought to myself, we have a particle model. That would be really interesting to do something. And lo and behold, Jeff is exactly doing that. And what I want to do is to pass this over to Jeff. You have the ability to share screens. Do bear with us. Of course, this is live, and we're going again to live to YouTube, the CMPS YouTube channel, also my Dissidents Science channel. And he's going to be talking about the project. And then, of course, if you have any questions. But really, the floor is yours. Welcome. Thank you so much. And please, if you have any questions, I will be monitoring the comments. And my question to you, Jeff, is do you want us to put any questions up that I feel relevant to what you're speaking now? Or would you rather sort of do a presentation and then open it up? What's your
Oh, it
thought?
might be easier if I start with the presentation first, just so we can
Okay.
kind of narrow down the questions that are going to be
Right.
asked today. Just I'd like to stay on topic.
Great.
And so I will share my screen. There's actually 2 things that I want to share with you, Dave. But let me just I'll kind of preface things first, and then I'll go over 2 things. And the 2 things I wanted to give an overview of the contest, and I have maybe 4 or 5 slides put together for that to understand the contest. And then I want to show you what's been developed so far, which is a simulator program. In total, thinking it's not going to take more than 15 or 20 minutes, so certainly we'll have time for questions about it. And you can either tee it up as we go along, or you can hold it to the end. Either works for me, Dave. All right. So let me start first with the goal. Why do this? And let's bring up the screen so you can see that. Green one. Is everything coming across, Dave? You see it?
We don't see it. Let me see if I can do that. There we go. I've got it there. You go ahead. I got it.
Okay. All right. The only thing I can't see is me or you when I'm in this presentation mode, but I think there's only 4 or 5 slides here. So just stop me. Since I can't see anything, just stop me if if you have any
Okay,
questions.
no problem.
All right. So the idea of this project, Dave kicked this off earlier, which is, theories that are now using Newtonian or classical physics instead, right? Because the issue within physics is the different laws, laws for the big and laws for the small, i.e. meaning anything that we can see with our eyes using classical Newtonian physics, anything smaller than the atom using quantum. And that's just at current speeds. And as you increase speeds, you have to be concerned with relativity. But let's just start with just quantum versus classical. Trying to unify those laws has been, goal, I think, of physicists for many, many years now. There's many different ways to probably attack this, but my thought, along with probably almost anyone that comes from computer engineering, is, hey, why couldn't we just use computers to try to simulate this and see if we can get down to a set of laws, based on a theory that can model not only atoms and molecules, but to get down to their parts. So, particles such as the electron and proton, but then getting even smaller than that, which is to be able to explain different particles that show up in accelerators, to be able to describe the forces that cause the motion of those particles. That's essentially the goal here. So I'll just read this objective that you see on your screen. The project is to simulate the creation of particles, atoms, and matter with classical laws, illustrating the universe operates under a single set of laws. So that's it. Pie in the sky idea, but going after people that have the skills in computer engineering to be able to see if we can do this. Now, the contest to kind of put this together, started with some high-level requirements and the things that need to be done to be able to prove this. And all this is on a website. I'll come back to this at the very end. I'll give you a URL where some of these requirements exist. But I've kind of left it very open and flexible, because the idea here is we want to encourage a generation of developers to be able to contribute to this as an open source project, right? So there's no rights that I maintain or anyone should maintain to this, that it should be freely accessible and easy to install. Anyway, so I wrote some requirements, and you're going to see a couple different options here. Dave referred to Blender as a computer program, a 3D creation suite, which some work has been initially done on, and another one that Dave referenced, Laura Gardi, has also been working on a simulator as well. But I've left it completely open on how this gets developed. It doesn't matter if it's Blender, doesn't matter if it's, pick your own favorite program to do. What only matters at the end is that something is proven, and that is to be able to explain the smallest of particles with Newtonian classical physics. That's the goal. All right, now, with the incentive, all right, I'm putting up 15,000 of my own money. I've already been approached by others who are interested to contribute as well. So this prize actually could increase. I don't think it'll increase in the first 1 or 2 phases, but if this project is successful and moves along, I think what we're going to do is increase the prize money in the later phases, but at least $15,000 over the next year. And this explains how the project is sort of organized now. It doesn't go after everything at once. If you think about everything from kind of largest to the smallest, you take molecules, which are made of atoms, and atoms, which in the middle have nucleons like protons and neutrons, and then you break those down into its parts like quarks, etc. Everything gets smaller as you go from right to left. And so we start with space-time and the creation of the smallest of particles out there, and to be able to describe that interaction. And again, I'm not going to get into any details, have to answer any questions, but the requirements are on a webpage. What I want to explain here is over the course of a year, essentially each project is about 2 months. And we just kicked off the first phase, which is called the space-time phase. And the end date for phase 1 is on November 1st. So we're a couple weeks already into it. There's still plenty of time if somebody is listening to this for the first time and decides they want to enter. There's still a month and a half to finish the requirements, which I hope is ample time. You can see the grand prize winner for each phase is $2,500, and the runner-up is $500. The way that it works is after phase 1 is complete, there's a judging period. I have a handful of judges that have volunteered their time to be able to review any entries. There'll be a 2-week period for judging. And then the intention, if all goes well, is that we take the winner from previous phase, and then that becomes the code that's checked into open source for the next phase, such that anyone can download that and use it as a starting point, right? Because this is just like physics, everything should be building on itself. Anyway, so there's the 5 phases over the course of a year. And then what I do want to show you is the work that has already been done, because there is code that's checked into open source. Actually, there's 3 different versions, different starting points, but I'm going to show you one that is very visual that was based on Blender. And so there are some issues still remaining with it, but it should give you a sense of what the project intends to complete. So I'm going to show this in just a second, but let me first go to that URL that I referenced earlier, which is the details of the project, the time frame, the contest, rules, just so we're clear on the legalese on how everything is paid out, and we have to restrict from certain countries if you are in different parts of the world. Pay attention to the rules, but you'll find everything linked off of that URL here on this page. So the next thing I want to do is show you, because I referenced this quantum microscope, which also, by the way, can be downloaded. If you use this URL right here, you'll see a link to quantum microscope or QScope. So you can download the it's called an add-on for Blender. So what I want to do next is show you the simulator that has been developed so far. But before I kind of transition gears here, Dave, you have any questions I've come across so far?
No, we just had some general comments. No questions yet.
Okay. All right, then, yeah, let me kind of do this part then in the next 15 minutes or so, and then I'll be done kind of presenting stuff and happy to take questions. So this is Blender, for those that have not seen it before. So this is the kind of very standard interface for Blender. And within Blender, and the reason why this was used at least as a visual tool to explain what is trying to be done with this project, and by no means, as I mentioned, does it mean that people have to use Blender. You can use whatever tool you see fit, but this is very visual. I like Blender just because they can kind of pan around, zoom things, and you don't have to kind of build this in. Now, as I mentioned, we have at least 2 other starting points built in. Laurie Gardy was building something in CUDA, and we got pretty far in it, and Laurie's done some fantastic work, and so that's also an option. But let me walk through the 5 different phases and close this up. This is where my mouse cursor is right here is QScope. This is an add-on. It does not come with Blender, so after you download Blender, you have to download this add-on. Now, once you do, you see this menu choice for the quantum microscope, and that these 5 first links here, this last one is settings, but these first 5 match to the 5 different phases that I mentioned within the project. So these are the different phases that are trying to be proven, with classical physics. And in short, without getting into the details of the requirements, the first phase, space-time, is really just to prove the motion of particles and the fundamental particle. The next one would be to describe all the different particles. The next one, the nucleons, atoms, molecules, are self-explanatory. So that's the idea, that's kind of broken off into chunks, very easy to digest, hopefully to build, and then to prove. What I want to do first is I'm going to show each of these 5 phases, stay at a high level, but if there are questions later, then we can go into more detail with anything here. I do see a question there that says, what platform does Blender run on? It runs on almost anything. Blender itself is open source. You go to blender.org, and you'll find that it runs on Windows, Mac, and I believe Linux. So I'm going to go through space-time first, and I'm going to show you an example. Let's take particles. I want to show you an example of motion of waves. Now, the model here assumes, I should also mention, by the way, when I click on this, it takes some time to think, because what's being done here is it has to kind of pre-calculate a number of things in advance. But what's being shown here is the motion of particles that are interacting. This would be no different than air molecules in air that have wave motion, or water molecules within water that are interacting. It actually is wave motion. It's very hard to see, and this is also 2D view. And so you see this different view here called granules or waves, and so I can switch this to waves. I actually see much more like when we look at an ocean, we see physical waves. We don't actually see the molecules themselves bouncing around. You see, this is what it looks like here as waves. And so this has been programmed into two different views here. There's a lot of different configurations here. It's quite slow depending on how large you make this. So I can make it a little bit smaller as well and run different dimensions as well. This is a 2D view because 2D is always the easiest to kind of visualize these things, but we live in a three-dimensional world. So you can change the different dimensions here, but the goal here in this phase is to be able to understand how a particle can interact with a particle that is separated physically in space. And we know a lot of that to be kind of wave-ish motion, and so this is a simulator to try to explain that. You can add, let's see here, let me go to add a couple different types of particles. David had mentioned charge earlier, so another goal within the first phase here is to explain that motion. You know, if it's not charge, what is it? And so this shows constructive wave interference between two or more particles, and everything here can be set so you can visualize what this looks like. One thing about doing this in Blender is all this is inherited, right? So I can take a look at this in any direction, I can look at it from afar, etc. That in a nutshell is space-time. There's a lot more options here, but like I said, I'm trying to keep this very kind of short and sweet to give you a high level of what the project is doing, because as I should mention, everything that you see in here is certainly not complete. If this was the working model, then there would be no reason to have a contest and payouts. So Blender can be used as a choice here. The source code for this Blender add-on has also been made available in open source on GitHub. But for anyone that wants to kind of replicate what you're seeing here in another program, completely free to do so. All right, as I mentioned, I'm going to walk through just a few more. Let me just take time to go through 4 more of these, and then I'll stop for questions. So particles. Particles here can be not only simulated, but calculated for energy. The idea here is to be able to explain what creates particles. So one of the nice things about Blender is Blender has all these different options where you can kind of turn things on and hide them. And if I sort of do this, you see a spherical shell here. It's actually easier if I do it this way, if I turn on this shell. And so this part of the phase now is to explain why do we see particles, what creates mass, and why are there so many different particles. But more importantly, is can it be accurate using physics, right? And almost everything that I've shown here is not using animation. It uses, Blender does have a physics engine, even though it's a very simple one. But the idea is to show everything in physics. So for example, the motion of all these things in the center that you're seeing here is not animated. It's creating that shape due to forces that are being applied, and those are physical forces. Okay, but again, I'm staying at a high level. I'm happy to come back to anything here if people have questions. Let me just walk through each of the phases. That was phases 1 and 2. Now, assuming we have built the reason for motion, you know, and then particles. Now from there we can build, from particles we can build nucleons, because what are protons and neutrons made out of? Well, they're composite particles, right? They're made of other particles. And so here, also using physics, right? So what this does is it kind of has a massive force that pushes everything together, and then this just naturally forms these shapes. In this case, it's a tetrahedron. But like I said, this is not animated. I can pan around and see this, and I can run it again. You'll see that there's this force that forces everything, and then see how they kind of just align themselves there. That's because of the physics that is being used here. So it creates this tetrahedron shape, and there's all sorts of fun things that have added into here, like particle accelerators. You can fire things at this to see what happens, and actually you can actually see and reproduce, you know, what happens sometimes in what appears as quarks and accelerators. Anyway, but I'm not going to go there right now. The next one is atoms. So once nucleons are formed, how do atoms form? I have to say this is like one of the more interesting ones that I hope everyone finds here, which is this could be useful for a lot of people that are studying chemistry right now. So if you're a teacher out there, high school chemistry, maybe even high school physics, this is modeling with physics the interaction of a nucleus with electrons and calculating different orbitals as well. So let me turn this up and you can see maybe more electrons now. You can see a 1s, 2s, and 2p orbitals here. Now, there's a different view here because oftentimes we don't see single electrons. And so let me turn this back down to, let's do this one. You can do show cloud, which shows the probability cloud of this instead. Each one of these electrons is doing an interaction with the nucleus in this case, just so we can show the probability clouds of atoms. Anyway, this section does everything from hydrogen to calcium. So 20 protons in here have all been put into this simulator and all using physics. Last one I'm going to do is molecules. So once we have proven that everything builds up to atoms, then molecules should just naturally form, and that's what this is intended to do. I have to admit that this section here uses a lot more animation than physics, and that's because everything in the previous steps have to be done first. But this is these are just hydrogen atoms, and what you're going to see is the attraction of hydrogen. You'll see them form molecular hydrogen, which is H2. As you can see, that one has already formed. These two are being attracted right there. And again, this part is not necessarily animated because if I run this again, they're just in random spots. They're not going to appear in the same spots that they were. So you're going to see different ones being attracted to each other now. But otherwise, there's a lot of animation within this one. So for example, I can add different levels of forces. So for example, within the sun, hydrogen does not form molecular hydrogen. There's a lot more energy in there. Instead, you see it fuse together to form helium. And so now you're going to see them being forced together, hydrogen, and producing two helium atoms in this case. And there are some leftover hydrogen atoms. Excuse me, I had to clear my throat. That is a quick walkthrough. Let me hit pause here and just summarize what I put together. So the 5 different phases, space-time, particles, nucleons, atoms, molecules, are the 5 phases of the contest. Hopefully this provides a good visual of what we want to accomplish with the contest. And each of these phases is worth about 3,000 total, 2,500 to the grand prize winner, 500 to a runner-up, and really can be done in any platform of choice as long as someone agrees to do 2 things. 1, follow along with the requirements, but then 2, it has to be put into open source at the end. Other than that, I've left it really flexible because the idea here is to ultimately prove that everything can be described with classical Newtonian physics. All right, that was my quick walkthrough, Dave. I'll turn it back over to you.
Wow, this just totally blows my mind. But I think let's do a couple of things because we do have people here who are just not familiar with things like open source, GitHub, any of that. Why don't you, before we get into I've got a million, questions myself, but it's just, first of all, fantastic, absolutely phenomenal. Um, Explain to our audience what is open source, what is GitHub. If I'm not a programmer and I've never, I don't know what I'm even looking at. It sort of looks like animations, all that, not the details, but give our audience what those things mean.
Yeah. Actually, I think you're probably more qualified than I am to talk
Well,
about it, given your software
well,
background. Let me give my 2 cents, and actually, if you wouldn't mind adding to it, but the idea for open source is that anyone can contribute to it, and hopefully no one's paying royalties or license fees to it. And then GitHub, which I mentioned, is just a popular kind of website slash repository for code that people use for these open source projects. So everything that has been created so far, like what I have shown here, is the Blender add-on has been posted to GitHub. So what that means is if I'm a developer, I can download that, I can change it, I can then post any of those changes such that the next developer is able to take advantage of that.
okay, yeah, and again, I'll even take it a step, a little bit higher, and that is, they're open source in the world of software means that you do not write code in your company or in a group that is proprietary. If I write a program, for instance, like Facebook, and I write that app, etc., Facebook doesn't give everybody their code. Um, the reason is it's because they make money from writing that code. The idea of open source is a philosophy that knowledge is knowledge and that it should be available to everyone. And in fact, those kinds of things are changing very much in the industry. I work for a company that makes supercomputer software, and numbers tend
Uh-oh. Uh-oh, Dave, I lost you.
readily get their supercomputer. Yeah, no, that's I think that was StreamYard because that wasn't either one of us. You still there?
Yeah, yeah, I can hear you now.
Yeah. So basically, software has normally been not available for anybody. Today and age, open source is becoming more and more common. That is, we're going to share this, and even commercial companies often are doing that. And the reason is it's a philosophy, and that's what Jeff is talking about. He's saying that this is human knowledge, basically, and he has come up with a way he thinks the universe works, and he wants to share that. Just like I think your book was pretty much available online, right, for free. That was what you
Yeah,
were doing.
yeah, as close to it as possible. Yeah, I had to go with the
Plus, yeah,
minimum.
yeah,
Yeah, I had to go with
it,
the minimum that Amazon does. Yeah.
yeah. But that's a great philosophy for those of you who don't know that. SpaceX, for instance, Elon Musk publishes almost everything he does open source. And the reason is because he is of the idea that we human beings were born, we're curious about the universe. We should be working together. If I want to make money off something, I can, but the knowledge itself, should be universal. So that's open source. Now, next to that in software, there's a thing called GitHub. GitHub is a way where it's a place, it's a repository that is available for everyone, and it's actually free for anyone who has computer code who will say that everyone can use it. So let's say Jeff, he has all his programs for his model. He puts it in the GitHub and he tells GitHub, this is open source. GitHub says, oh, if it's open source, you can do that for free. And the idea, GitHub, and there are a couple other ones out there, but GitHub is the primary one, is where you can go and find this huge amount of software who follows the philosophy that knowledge and software, a lot of this software should be available freely for the public. So Jeff Yee has made his software. He's got Blender. Blender is open source. That's right,
Correct.
Jeff?
It's open source. Yeah, so anyone can
So
download Blender
right,
for free.
and it's not only you can download it, you can download the code if you're a programmer and
Yeah,
change it.
yeah.
So that is the philosophy, and going with that philosophy, the new programs or the new theories out there, and I knew this was coming because my father and I had the same idea, and that is this knowledge is open source. It should be everyone's. It's not like Einstein's theory, which when before he died he willed his theory to the university in Israel, who
Yeah.
made $12 million a year. I'm not kidding. It was the second most grossing scientists on the planet because you could not. Steven Spielberg in the movie AI paid $600,000 to show 3 seconds of Einstein in the movie. So that kind of old style of looking at things, that knowledge is somehow elite or is worth something, that's today and age. There's a generation out there who I think wonderfully believes that knowledge is for everyone, should be available to everyone. So open source means it's software that anyone can get, modify, put back, and the repository for that is GitHub. So you use let's see if we have some questions here. I don't know anybody has any questions. If you do, please put them in the chat. And also, if you want to chat, we do have live available. I think we have all of them filled. So if you are in our green or live room, that is live. Let me put this up here, live.naturalphilosophy.org. Can't find that right now, but I'll put that up on the screen. So if you go to live.naturalphilosophy.org, you can get into the green room. But we have a lot of people in the green room. And if you are in the green room and don't plan to come on screen, I would ask you to kindly leave your seat, come and watch via YouTube, where you can still chat. If you're in YouTube or Facebook, you can still chat and put in your questions there. But if you are in the live group, I want to emphasize that is for people who want to come on screen and talk directly. So I do have 10 people. Are there anybody here in the waiting room that would like to come up and ask a question? If you do, wave. Or oh, I do see someone, and I'm not sure I should let this person in because he is our host as well. I will add him to the stream, and that's Franklin. So I'll let Franklin ask the question. There you go.
Hey, Franklin.
Hey, Jeff. So I'm excited about this Blender tool here. So I'm glad you brought this up because and probably also James, because we're always looking for something to kind of simulate. Like the only thing I had before was basically like the Java applet for simulating, say, charges. It only worked in 2D.
Yeah.
So, I'm not exactly sure how is it that it works the physics for 3D? Because like in the Java applet, I was just saying, you could do things like set things like resistance, because otherwise the physics would say that these things would just bounce against each other endlessly and stuff like that. So I've loaded Blender and I'm trying to get the add-on to work so I can just start playing around with it. But I was wondering, how is you have to set some configurations, right?
Yeah. Oh, so you just downloaded Blender and got the add-on just in the course of this call?
Yeah, just in the course of this call. I'm about to turn on the
the
add-on. I was looking at your instructions.
Yeah.
They look pretty good, because most instructions for open source is just absolutely horrendous. So if you know exactly what you're doing, those instructions would be fine. But for newbies, usually it's pretty hard. But I like your instructions, so.
Thanks. Well, let's see. How do I do this, Dave? I think I'm still sharing my screen, but I can't tell if it's being shown right now, Dave, because I want to. Yeah, thank you. All right, so let me answer your question here, which was, I think your question was 3D. How does it handle the physics for 3D? I only showed everything in 2D, so let me switch to 3D. The only reason I avoided it is, well, two reasons. One, it takes longer. There's just more calculations, but it's also harder to visualize. Let's do this. Let's go back to this mode right here, just so you can see it, Franklin. But the physics is handled, doesn't matter if it's 2D or 3D, it's just naturally within Blender. You can see it's a little bit slower here, but you see all the different motion of these particles. So each one of those is being calculated and in three-dimensional space. So it's going to be harder if you have to pick like one and take a look at it. And I can rotate around in different directions, and you'll see that it truly is moving in maybe X, Y, and Z different coordinates. But all that is a part of standard Blender, I think, is the answer to your question. I mean, there isn't anything that had to be done specifically for this project, but this project has to be able to utilize that, right? It has to describe what are you trying to do to be able to simulate. But thankfully, Blender has a physics engine, even though, as I mentioned, it is simple, and there were some issues that were run into it that it just could not do. But simple things like motion of where things are going in a physical 3D space, X, Y, and Z, absolutely can do.
So when you run this in Blender, of course, the first question is that did it run according to what you would predict, which is that if you have two, like you have the red and the blue object there, if they are generating waves in phase, do they, say, push themselves apart or out of phase? Do they come together? That would be the first experiment I would run.
Yeah, absolutely. So that is one of the limitations of Blender, just the way that this was written. But doesn't mean, I'm not ruling out that Blender can't do it, but just the way that I'm showing wave motion is difficult. I'm going to get into the specifics, here if there's a Blender developer listening, but as collision objects. So anyway, just the way that this is set up for waves and collisions were kind of didn't work together. So all of that has been noticed. So basically what that means is if someone takes the Blender add-on as the starting point, there's all these notes that have been written about what needs to be fixed by a Blender developer. Otherwise, you can choose a different route and use a different program instead.
See, for me, the first thing I would try is I would make those main spheres expand and contract like balloons so that we can get a wave coming out of those things, and then see how those two things react. Because these kinds of experiments have actually been done with physical like diaphragms in water, and those have been shown to actually generate actual attractive and repelling forces. So I'm thinking Blender should probably be able to show that.
Yeah, so I mean that's the let's go back to what Dave was describing as open source, and everything should be freely available. I completely agree with Dave, and that is exactly why we do projects such as this, is that it should be able to be done if it's not with Blender, with another program. So you take an idea like that and say, look, these should be able to expand and contract and build it out. And like I said, my goal here is to provide the incentive for people to do that, and that's why we structured it in kind of bits and pieces for the phases of the project and the monetary incentive to do so.
But have you yourself at least solved that particular problem about showing that oppositely charged particles attract? Do you have a model that works doing that? Or is that one of the things that's just still open that you'll give the price for if someone figures out?
For doing it at this level, where you see here, it's completely open. So someone can do that and win a $2,500 grand prize for this phase. You'll see in later phases though that there is the interaction of particles. So two positively charged particles, for example, will repel. Opposite charged particles will attract. So that is actually built into some of the later phases. That is quite possible in Blender.
So I don't quite understand it. You said, have you got it already in Blender, or
so
is that something that...
my answer was for charges. The motion of particles based on charge is in Blender, and it is in the later phases. So when I was going through these different modules that you see here, still showing my screen, right? So as I go through here, when you get to nucleons and atoms, though it absolutely is in those phases. But the proof of it, though, belongs in an earlier phase, and that has not been done, and that is actually written into the requirements for the space-time phase. So what you described is absolutely one of the things that's on that checklist that needs to be done in phase 1, and that's why there's a prize associated with the winner who can do it.
So the nucleon level, that already assumes we have charges, and they already attract via the Coulomb force. That's kind of like what the particle world Java applet I was talking about
Jeff,
presumes.
I think there can be a clearing up here, Jeff. From what I understand in Jeff's model, I don't want to put words in his mouth, is that he does say in his model as a requirement that charge, in fact, doesn't exist, that the what charge's result has to be explained. Is that correct, Jeff?
Yeah, you're absolutely correct. Yes.
So the question, I guess, could be is in your own mind, Jeff, in your own model. For instance, we have a model, and if someone asks that question, we can give them an answer from our model. We don't have a simulation for it, but is that something you have already described, or is that a part of this endeavor in the project?
Yeah, so I think yes has answered all of them. So yes, I do have my own idea of how it works, but theory is a theory until you can prove it, right? But yeah, that is documented on the website. So everything can be kind of traced back if you want, but it leaves it quite open, right? It doesn't mean that just because I have an idea in mind of how it should work, that is the one. The goal of making this a computer simulation, I might be wrong about certain things, but the ultimate goal is just to prove that you can produce a charge, but at this smallest level of detail. Why? Because it gets inherited later as you move along in the phases. Charge is just a property in there, and so particles will attract and they will repel, but it has to be proven in an earlier phase. Does that answer it for your question?
I think it does. I think one of the things is too. I also was listening to Franklin's comment about, well, why don't you produce waves or those particles to move around to produce waves? And I know the answer because I've looked at your model quite extensively. It's like our model. You can't just say particles are moving back and forth, right, Jeff? I mean,
Yeah.
there's got to be a reason why they do. And that's one of the things I think in a lot of models, people say, well, there's this motion, there's this, and there's that. And you then the question becomes, well, where does that come from? So the idea, I think, in your project to take two, go in there with Blender, put in two of these, the red and the blue balls there, and then shake them in the middle. You can't just arbitrarily shake things. They have to have a reason to be shaking, and is that correct, Jeff?
Yeah, absolutely.
So I think that's one of the things people don't. And I think what it comes down to, I think, Jeff, is a lot of times when you're looking at the Newtonian world, when you're looking at a model that's going to be totally based on the Newtonian world, it's really, really, really hard for so many people to get in their mind that certain things like charge has to be explained at some level, that it is simply an attribute that Benjamin Franklin, it turns out, that put the positive and negative. He's the
Yeah.
guy who started that. And I think a lot of times when I've talked with people about, especially charge, I talk about it all the time. You take these four models: the infinite universe model, the ether model with Lionel Denis and Laurie Gardy, the energy wave theory, the particle model. All four of those models do not have charge in it, and that is the motion that we look. And my father's electrical engineer. We're doing entire circuits with our model with no charge, and that I think that's so difficult at times for people to extract that
Yeah.
when you talk about it and when you get a real model, they want to start wiggling stuff. They want to start messing this. Well, hey, this is a ether, so let's move this and it's going to produce waves.
Yeah. Yeah.
Yet the truth is, I always had the same question, and I think you do, and I think the people who are doing what I call the more sort of modern theories, it's like, folks, you can't just, again, arbitrarily have these things happening. There's got to be a reason. And one of the questions I have for you about the actual model, which I've always find fascinating with you, and this has to do with the tetrahedron. It seems, if you look at it, basically, if you just look at it in a structures way, I'm going to be leaving. Unfortunately, I have to leave a half an hour before this ends. I'm going to be talking with the structures group, and they're based on Mr. Fuller. They only worry about what these structures are. Now, Jeff Yee's model will tell you why those things exist, how they get there, but they form in certain ways. Tell me when you showed that part on Blender, it blew my mind. Tell me about that tetrahedron automatically forming, and then you said, I'm going to send a particle into that sucker and hit it, and that then will be reacting, and you're not calculating. You don't have equations for that. The formation of the tetrahedron happens on its own. That when you hit something and its stability is on its own. Tell me about that. That's mind blowing.
Sure. Well, if you wouldn't mind, flip back to the screen and I can show this. That was under nucleons. Let me click on this, and this is what I was showing. So let's run this, and then I'll pause it and kind of walk through everything in detail to explain it. Let's just do this.
Yeah,
zoom in here. So let's pause, and that's a nice thing. I can go back frame by frame, right? So if we start here, all of these these are like electrons or just anything that two like particles with the same color would naturally repel, right? But what it's doing is it's applying an external force. So this part uses physics where it kind of forces everything into the center, and I can change that's a variable, the strength of the force. So I can really smash them together at high energies if I want. Anyway, let's fast forward again. And you see that right here, they kind of ended up there, and then see how they rearrange right there. And if I run this again, you'll see there, because they start off in random different locations, they always end up in the same thing, in a tetrahedron. Now, your question is why?
Okay, wait. Hold on. And I don't mean to stop you because I want to make sure people aren't going to be lost, okay? Because I get this because I know what's going on. Maybe if I can explain it from a different point of view, people will get it. What's
Yeah.
happening here, folks, is the particles have been formed at a lower level, correct?
Yeah.
These particles have been formed at a lower level with a Newtonian process that's already happened. Now we are up a level. And these particles are in the vicinity, and their movements isn't because I think people could get the idea, Jeff, that these movements are okay. I'm moving them in, and I'm simulating this. Explain to me before we get to even that how the tetrahedron. These particles are formed. They're near each other. Why are they moving together in the first place?
Yeah, so let's assume, maybe a process like in the sun. That's more like the molecules example I showed earlier, where you force them together with energy and they fuse. So you have to assume there's some sort of energy that, in the case of nucleons and the creation of protons and neutrons, I mean, maybe they were formed in the Big Bang, I don't know, but you have to assume a lot of energy that causes particles to come together. So if you have those conditions, this is what happens. And let me show you one other fun thing about Blender, which is I can turn on and off. Let's do this. Let's put a shell around this now. And there's this property called X-ray, which is, where was the X-ray one? Oh, I have to remember my Blender now. Oh, X-ray. Oh, I don't remember where it is. I'm not a Blender expert, but you can actually X-ray into this and show what it looks like inside. And so it actually looks like, and you'll see this on my videos. So just go to see the video of this. But it looks like the composite particle, with quarks inside of a proton. In this case, I just can't remember where the X-ray feature is. Somebody else whose Blender might tell me here in chat. But let's do this though, because the other thing you said is you want to see what it looks like when something is accelerated into here. Let's turn back to this view. Let's go to a particle accelerator now, turn that on, and we show you what happens now when we shoot a target at this. Whoops, let's back up. So you can see there's just slight movement. There you saw a particle starting to move out, but I can increase the strength. Let's make it a little bit more. And you see different things happen at different strengths. This is basically energy. So this particle now has more energy that's being directed at this. And you just see the different types of things happen. And now the important thing about this one, which I want to run now at a much higher energy level, is we're going to see this, instead of just barely break up, you're going to see 1, 2, 3, 4, 5 different particles. The reason why I wanted to show that with increasing levels of energy is, of course, 100 years ago, when the proton was discovered, the proton was thought to just be one particle. Fast forward to the 1960s with accelerators, then it was found to be made of 3, quarks. But more recently, in 2015, as the accelerators have higher and higher energy, the pentaquark has been found. And the pentaquark is made up of, I can't do this right, and scroll that over there. The pentaquark is actually made of 4 quarks and 1 antiquark, and that's exactly what is modeled here, right? It's 4 like-charged particles and 1 anti-charged particle at the center.
But you're talking about charged particle. Now, how is it charged part? Is that because you're using mainstream terminology?
Yeah, well, so one, I'm using that because it's easier for everyone in physics to understand. But here in Blender, it is actually using charges. So as mentioned, Blender has a physics engine, and one of those properties is charge. Now, to Franklin's point earlier, charge still needs to be proven, and that's what's a part of the space-time requirements to do, so we can understand charge better.
Okay, so in other words, you are using that at this level just the same way you're using those spheres, which are really more visualizations. You're also using terminology that makes it just simpler to talk about, because obviously if you know everything from every level, you're not going to sit there and talk about every collision necessary in the Newtonian world, which you and I happen to agree on that, to explain that. So you're doing that for a matter of just organizational, for looking at things at different levels, which I know in our particle model, it's the same way. You have to sort of concentrate on a certain level, otherwise you'll go nuts trying to go all the way down.
Yeah. Yeah, not only to be able to speak to it, but also for computer simulation reasons, performance reasons, and I think you'd
Right,
appreciate this,
right.
right? Is
Yes.
imagine if we had to have all those interactions, granules in my terminology, but whatever someone wants to call it. But if you had to have all of that in between each of these
Yep.
particles, it would take days, if not months, for it to calculate and run. So that's why everything was divided into chunks, right? You prove it
Yep.
at an earlier phase with the smallest, all these tiny little granules
Right.
and a simple particle, and then you inherit that in later phases because you can't simulate all those tiny little details as you get
No,
larger.
no, I get it. So I think that's really important because one of the problems will be, for, of course, is if people don't understand that, they're going to say, oh, of course, you've got charge in your model. Go to this level and it's got charge. It's they just have to understand, the model, how it's all built one level on top of the other for
Yeah,
them to understand that because like I said, there's a lot of discussion, just immense amount of human brain power going and talking about charges and moving charges and do they produce electric fields and does the field affect the charge or does the charge create the field, those kinds of things. Quite a lot of brain power going into those questions, and when people see this they're going to go, oh, okay, this is charge. So all right, so we're looking at each level now. Each of the Blender projects have a level, and they, of course, are assuming. So I have a question for you. We have some more questions going on. I still have a little over half an hour. I'll be here. One of the questions I have is who built these initial levels? Because these, it seems to me, or maybe I'm not correct, that you have your project with the prize money. Um, did you did some preliminary structural work and basic work of setting this up? Who did that? How did that happen?
so I've been working with Laurie Gardy for probably almost a year now, and sort of trying to describe things in a simulator. And then at some point we decided, let's break this down and create a contest out of it. Um, Now I started to work on Blender myself. Actually, let's give credit back to someone that I've been working with. Chris Seeley is his name, who gave me the idea to try to put things into Blender. Now, originally I put it into Blender because I wanted to be able to communicate things. It's just more of a visual tool about what could be built using a different platform, namely to help Laurie describe what was being built in the simulator. And then at some point realized that this is such an easy tool in terms of add-on capabilities, which means that other people can just download it and extend it themselves. That I thought I would just turn over what has been built as visuals and make it a part of the contest. But no, I'm not expecting that people use Blender to ultimately to prove everything that's a part of the project. In fact, it may very well likely be other programs instead. But I think this is a very, very powerful tool to be able to illustrate and see the interactions of particles.
Well, I think also, Jeff, the truth of the matter is, and I know it's the same way with our model, um, the most basic and most important parts of any model, at least now I'm calling them more the Newtonian models that describe everything, even the quantum area, is that at the level, those are the building blocks. So if in reality, Blender, when you isolate something at that level, should be able, those are important building blocks. And as we get higher, of course, that those things change. And I think it's interesting to see. One question would be I have is how I've got some other here waiting in the wings, but it seems to me it's interesting that you have the Newtonian collisions at the very bottom, and you have charge, how those kinds of things happen. As you go up, you necessarily start to have to, even in the simulation world, as you said, you can't simulate all that stuff. I mean, you have to have a supercomputer the size of galaxies to be able to do that. The universe can have that if there's infinite levels up and down, yes. But as you go up, then of course you have to build upon that model. But in the end, Blender should be able to, at the very basic level, tell us the inner machinations, as Patrick and SpongeBob says, of how the universe works.
Yeah.
So as much as it's simple, is that true?
Well, I mean, The hope here is that we can simplify physics in general anyway, as going back to what we had started with, classical Newtonian and quantum physics. So Blender is certainly simple. I'll give that. Easy to communicate. The physics engine itself is simple. It may not have everything right now, though, to be able to achieve even that. Like, let's try to make physics as simple as possible. But to me, I think it's just a wonderful tool for communication. Which hopefully, I got my point across about what this contest is.
Sure.
Just in the 15 minutes I was showing everything here. But to Franklin's point, there are still a lot of things that are not in here, don't work. And that's exactly the reason for the contest. It's laid out very specifically about what needs to be proven, and there's a chance for people to win money.
Okay, I'm going to put some of these questions up here that we have. Let's see, go here. This was up before, but this is Jim Marison. How does the physics engine deal with electromagnetism?
Oh, so if the question is specifically the Blender physics engine, and I'm not going to pretend to be a Blender expert, but I can at least answer that question. There are two different controlling forces. Well, just for electromagnetism, there's actually more forces than that. But there's a standard force, which is essentially like an electric force. It can do motion in the longitudinal direction. Blender does have a force for magnetism as well, so they are separate, basically the electric force and the magnetic force. I found that the magnetic force was not working for what I needed, which was static. It's based on velocity, instead.
Mm-hmm. Okay, and I guess the other sort of corollary question, just in your model before, I know we're talking about the project, but and I think one of the things that I think I can see happening is because of, and this is part of why you do it, right? Let's be honest, Jeff, is that this kind of thing where you can see it, you can go and download it, and you can play with it. Obviously, one of the absolute reasons you're doing this to spark interest,
Yeah,
correct?
exactly.
And so one of the things I'm thinking we're going to have to do is to have you come back and talk about the theory itself, because the even though you've talked several times, it's going to spark new interest. A lot of times people are going in that interest, they're going to have questions. So hopefully we can have you back on a separate session and discuss this, because obviously if people see, oh, this is real, people are really simulating it, then what are the bigger answers that physics has that it can address? So
Yeah.
here's another one from Don Mitchell. Is the model simulating charges effects over time with an iterated small movements over a field area affected? That's pretty detailed.
Time. Iterative small movements. So I think the answer to this question, if I understand it, goes back to when Franklin was asking the question in the space-time module, right? Because that is the small movements, basically the field, what is moving and then causing eventually that particle that is at a distance. So if I understand this question correctly, the model is not, and that's one of the things that needs to be proven. But just to be clear, and I think we've already said this before, I think it's worth reiterating again, this is the type of question that needs to be addressed in the first phase, because it gets inherited later. So for example, when I was showing the particles interacting with the nucleons, that was using charge. But I think this question goes back to the same one that Franklin was asking, which is, can it be proven at the minute, small level of detail?
Okay, I have another question. I'm having some people who aren't pasting these in the private chat, but it's a general question, so I can put out here. I'll just put it out and then display it for us. So here's one from one of a person, I think it's Eric here. He said, by physics, what are you talking about? Newtonian? Also, he said, using physics is not simulated. Also, wave motion, are you making waves from the collection of particles? So there's I think some of these have been answered. Newtonian, yes. Also said that physics, using physics, not simulated. I think we've talked about that a lot, where at the very bottom level, you get into, it's just basically collisions, whereas in the higher levels, of course, it's more, how do you say, attributes that are coming from lower levels. But I think another interesting one here would be wave motion. Are you making waves from a collection of particles? The whole, I think this maybe comes from the ether kind of question.
Yeah, yeah, it's wave motion from basically Planck length size radius, actually, size particles. Correct.
Okay. All right. Wow. You've always been a succinct person. I have the opposite problem where I often way go on. And of course, I think this one has been answered. What part did Lori have in this? And I think it sounds like she was also not only that encouraging, perhaps some of this ways to do it. Did she do the actual programming in the beginning to set up the blender of some of these levels, or were there several people involved?
So as I mentioned, there's a couple of different tracks to take because you can start at a lower level. In Lori's case, C++, the programming language, right?
Sure.
And then she used a graphics program called CUDA.
Right.
And so that exists, and that is actually another option that has been checked into GitHub as a starting point for developers. Now, developers don't have to choose either Blender or Lori's baseline. They can choose something entirely different as well, but they should both give starting points. But yeah, so Lori did that work, and Lori also did a ton of encouragement while I was working on Blender. And the other person that gets a lot of credit is Chris Seeley. He's a Blender guru.
Oh, okay. Well, that's good. Very good. And what a sort of a corollary question to this is, what is your involvement in software? What do you know?
Oh, not much. So let's be honest. I am not a software developer. I work in the electronics field, and I do marketing, business development, and well, actually, many different things. Software development is something when I first started my career 25 years ago that I did, and so I had to kind of dust off a lot of that knowledge to be able to do.
Okay, so you're not a software person crazy like me, but again, that's great. Let me see what else we have here. I believe we have some. Again, is if you have if you are in our waiting room and want to come up and talk or discuss anything directly with Jeff, that would be great. That's why we have our waiting room. And for those of you who don't know it, we do have our waiting room where you can go to live.naturalphilosophy.org and you can come in and join us. So if there's anybody in the waiting room wants to say anything, wave, yes, no. The people are not that brave, I guess. Let me look at some of the. There's a wave. Oh, Ian, of course, wave. He's going to be nice and rescue the host by participation, whether he can do it or not. But I'll add him to the stream. Great to see you, Ian. Again, I want to thank you and all the people. A lot of them are here today who've been doing these Saturday mornings. I come in and take over and pretend I'm like some great person, but you guys have been keeping it along, and the discussions have been great. Congratulations. You wanted comments or a question to discuss with? Go ahead.
Yes, well, thank you, Jeff. But I think you'll have to forgive me somewhat because this is my first exposure to this system, Blender, and so on. So my question might appear to be fairly elementary. But how shall I phrase it now? I'm interested in your initial comments that your endeavor, I suppose, is to show that basic Newtonian physics, what a lot of us conceive to be as rational physics, can deal with the whole panoply of experiments and results that we have. But my question is, it appears that Blender is really just a tool to correct me if I'm wrong here now, a tool to help you to simulate a system. So whatever you put in is going to determine what you get out. So presumably you could put in a system which would require a divergence between Newtonian physics and quantum mechanics and relativity. In other words, you could put in a system whose output would be through Blender that quantum mechanics and relativity, special and general, are essential attributes, contrary to what your aim is, I think, to have Newtonian physics as being sort of a unifying principle.
Yeah, that's a fair point. It's probably worth noting how Blender got started and what's in it right now to answer that question. Then I'll come back to how could somebody kind of change course in the future. But I think Blender is a little more than 20 years old. It's film studios can use it as a free alternative because it's open source and free compared to the visual tools that they might use for 3D graphics in simple films. Now possibly even in movies as Blender continues to grow and improve. So if you think about it from that perspective, where it's used as kind of graphics in films or videos, they needed something realistic in terms of physics, right? If you're going to kind of animate something and a ball is dropping from the sky or an airplane is landing, so a physics engine was built in such that they can use that. But like I said, it is kind of simple. I think it because of the purpose for Blender, it doesn't simulate everything that we need for particles, and so for that reason, I use Blender as really just more of an illustration tool. What it can do, but I also left it open for Blender developers that actually can influence what's inside that physics engine to make those changes. Now, to your point, they could change that, and instead of being Newtonian physics, they add a lot of quantum rules in there in the physics engine. Yes, entirely possible. But right now, given the history and everything's kind of the macro view, we want to simulate things for video. It's Newtonian physics that's in there today.
Okay, and just to come back very, very briefly to your competitions. So what you're endeavoring to do here is to have these specific add-ons. Am I understanding that correctly?
Yeah, just for the terminology, the package that you download is called one add-on. So there's one add-on right now. The title of it is called Quantum Microscope. The modules that you saw in there when I was clicking on the different titles, space-time and nucleons, etc. Those for terminology, those are called modules within the add-on. So it's one single add-on.
Okay, thank you. I'll have to look a little more at the web and so on. Thank you for that.
Yeah, absolutely.
All right, thank you very much, Ian. Greatly appreciated. Also, I have somebody waving is James Keene, who's also been participating in the Saturday mornings here. So another person who's been very instrumental in a lot of the discussions. So go ahead, James. You had a question or comment or discussion with Jeff?
Yeah, well, my question is I would like to see the physics where you start. In other words, the Blender illustrates that physics by animating, as Ian said, what you put in. What I'd like to see is what is the physics that you have, what is your theory? And for example, what is the size of these particles? What so that's, I guess, my comment and or question. It's just that perhaps as we move along today, or as David said, in the future, it'd be good to have a session. Forget about illustrating your theory. What is the theory? We need numbers. We need the math. Rather, as Ian perhaps was implying, it's sort of like you're saying, I can download this black box based upon basically 20th century, that's the previous century, physics ideas, and just make it an animation program. Well, wonderful, but I think it'd be more interesting to actually talk about physics.
Well, let me answer just really quick before Jeff goes. Number one, we have had sessions through our video sessions in the CMPS with Jeff, and he has also presented his theory quite a lot. Also, I think a number of times, at least one time I can remember at a conference that we had, that's also recorded. Also, this website that I have listed there is absolutely extensive. It's one of the most well documented theories and models I've seen. So if you go to that website, not only does he have all
Okay.
of these things explained,
All
but he
right.
also has a lot of really great videos doing that. But I think we should do that, and I think that suggestion is correct. And like I said, Jeff, I think you're seeing that the interest is there, and it's going to be a chicken and egg where we're going to have to maybe come back and talk about that, and maybe even talk about the theory on top of what you could think about, Jeff, would be to come back and let's talk about the blender, but we'll use that as sort of just a parting point here. Okay, this is where this is happening. Here's the theory behind it.
Yeah, yeah. So I think actually Dave answered it the right way.
You talk about.
Go ahead. Yeah, I'm happy.
You talk about the.
There's a delay.
Go ahead. I'm sorry.
No, go ahead, John. You go ahead. Just go ahead and the answer, and then we'll get James to speak, and then Jeff has what he's going to say. Go ahead, James.
We just need to know, like I think you've answered my question that the actual physics and math here is in a different location, on Jeff's site and so forth. So that's a point well taken. That's basically answered my question.
Yeah.
Okay.
So to Dave's point, I think thanks first off for putting out the URL up there, because I do try to document everything to be able to answer questions like this. I was fearful that if we went down the path of answering, one question about the theory, it would lead to, any different direction. And I wanted the focus of this to be a call to action for the contest itself, because the idea here is just to come up with a solution that simplifies particles, as we stated at the very beginning here, using Newtonian physics. And I've left it very flexible, right? There could be some things that I have in mind that are incorrect. It doesn't matter. What I'm trying to achieve here is the end state. Now, that being said, if you have questions, about the theory itself, that's why the URL exists. And I'm also happy to come back at a different time to talk about it in detail as well.
Okay, I do have another person. Thank you very much, James. Thank you so much. I see Franklin waving frantically there. And again, I'll be here until 11:30. My dad, as you can see, is sitting right. Well, I can show you there. He's sitting here. He's going to be sitting in for me. So I hope Franklin maybe can help out. Franklin, do you have all the controls with you? Just as this is just a production.
Yeah, yes, I do have all the controls. So
okay, so then
in fact, I could have added myself on at any time. So
he could have taken. I was afraid of that. I was really deeply afraid of a hostile takeover. Yeah, just delete them. Yeah, exactly. It's the cancel culture. Now, of all those people who have no idea what we're talking about, the modern younger people maybe know that. But yeah, go ahead, Jeff. And what I can do, Franklin, I'll have you sort of take it. I'm going to have my dad sitting here just in case. But at 11:30, when I have to depart, maybe you could take that over. It would be great. Do you have any experience using it? I'm kidding. Okay. Go ahead.
Yeah, I can take it over as, help get people on and discuss things.
Yeah, yeah. So I just want to say, if anybody's kicked out when I leave, I'd like to know about it. That would be the dictatorship of Franklin there. But hey, Franklin, go ahead with your question. I'm going to remove myself here, and you can question or comment to Jeff here.
Yeah, I had a comment, about what Ian was saying, because I was kind of curious, because I'm playing around with the simulator right now. So I ran an atom with, say, 4 protons and 4 electrons, and it shows the electrons kind of staying in. I mean, they're not orbiting, but they're just kind of staying at a certain spherical distance away from the protons, which are all grouped together. But if you're just using the laws of physics, then all the protons would try and get away from each other, and all the electrons would collapse into the center. So I was just kind of wondering, what was done to kind of enforce things which are not really actually against the laws of physics, especially against Coulomb's force?
That actually goes back to everything is built in steps, and you saw that previous phase was nucleons, so nucleons before the atoms phase, and so it was first proving the tetrahedral shape of that proton, and in there was if you recall, there was the antiquark and the quark, which in my model is the positron and the electron, but it doesn't matter. You don't have to believe in the theory just to understand the pentaquark has an antiquark and a quark. Now from there, when you align those, it's a dipole magnet. So the physics that is used in atoms inherits from that phase. It uses a dipole magnetic repelling force, and then it uses an attractive force at all times for that anti-quark in the middle. So essentially what it's doing for the atom is it has two forces. One that's repelling and one that is attractive, and where the sum of the forces is zero is where that orbital is. The challenging thing is that the nucleus is spinning, and so that it's kind of changing at all times where it repels. The best one to show the example of that it sounds like you did the 4 electrons and 4 protons. Just do hydrogen. Just do 1 proton, 1 electron, and you can actually zoom in and see that interaction.
Okay, that's interesting that that's built up from the previous level that you had there.
Yeah. That is entirely the reason for the phases of the project, is that everything has to inherit from the phase before.
All right. Well, I'll tell you, the first experiment I'm going to do is I'm just going to get, because I also noticed in your nucleons that all your positrons somehow always melded together into like a single ball, right? Which is another thing that I don't think positrons would do on their own, right?
Sorry, what do you mean by melt in a single ball? I'm not sure I understand.
I put in 4 positrons, and what happens is you initially get 4 red balls, but then all those 4 balls go and combine into a single central ball.
I understand what you're saying. It's it was just designed around electrons doing it, but you can consider that one a bug. I know exactly what you're talking about. It wasn't really designed for that scenario, but yes, I understand what you mean.
Yeah, because I'd love to just simulate just what happens to just a bunch of charges in free space, and do they just form a random ball? Do they form certain geometric patterns which are more stable than others? Certainly, that's certainly what say my own atomic model is saying, that it has to form very specific geometric shapes. So things like them coming together doesn't really help me any. So that's I would rip out of it first of all.
Yeah, so the nucleons, well, I'm actually glad you brought that one up, because Blender and even the add-on I built can do what you have in mind, but each of these modules has very kind of specific goals in mind, right? So the goal of the nucleons model is to be able to show a composite particle. It's not to show electrons and positrons freely in space and their motion, but it can certainly be done. And so there'd be some added work that you could do in Blender to be able to do it. But you're not going to find it's just something you click in this module interface to do.
Yeah, so I'm excited to. I'll probably work on that. So I got to see whether space-time works, because I certainly have some ideas about how it works. I mean, a lot of my theories are very similar to yours. That we try and reduce things down to, say, Newtonian physics, and Blender can certainly replicate Newtonian physics at just things colliding into each other, going to and reacting according to F equals ma and stuff like that. And to show that things can arise, like we're saying that the force, charge force, is something which arises out of Newtonian physics. It's not something that you can use as just a postulate, I guess. You just can't say that electron attracts positron and that's all there is. There's got to be some Newtonian method that's causing that to happen. So
yeah, I agree with you. Actually, can I go to one point that I realized I completely missed earlier, since you're talking about extending this now? One thing I forgot to mention is how this is developed within Blender. So the add-on uses a programming language called Python. So if you're familiar with Python, it should be easy, Franklin, for you to kind of pick this up and make changes within Python. There are some things that are within Blender's core, and David mentioned that it is even Blender itself can be downloaded, the application, because it's open source. People contribute to what you see here. That's the reason why it's free. And I believe that's C++. Now, just to be clear, I haven't touched anything within Blender itself. I did everything kind of at the surface level, which was Python. And Python itself is pretty easy to pick up. I mean, I started just earlier this year programming in Python. Like I said, I don't have a huge background in software engineering. I started my career, but that was so long ago that I couldn't use any of that. So Python is something I had to pick up to be able to build this.
I'd say we've got some other comments here. Let me just put up some of these comments. We've got a lot of comments in YouTube here.
The single particle level does not ensemble. It seems you can't explain that. I'm not sure if I understand this. If this question is related to Blender or the theory itself, you will find in the theory, and Dave showed the URL, that it certainly have an explanation for it. I will say that in the space-time module that was shown earlier, it is illustration, but that's exactly the reason for having a contest and inviting developers to improve upon it. So I would agree that this is not the proof of it, absolutely, but there is a theoretical model behind it, though.
Here's another comment here.
We need to figure out the true units of mass and time before we know. Yeah, so I completely agree with this one as well. The units of the units of almost everything, I think, has been one of the sources of complication within physics. So there is a page that I have dedicated. Again, if I answer this one in detail, we kind of go off in different paths. But I do address units specifically, and how they can also be consolidated, maybe simplified. But I would agree with the statement that unless we really figure out the units, it's hard to model almost anything. Completely agree.
Okay, let's see what other comments we have here. So yeah, if anyone who is watching on YouTube, just go ahead and put in your question if you would like to ask a question. And of course, anyone else is in the live room. I see we have Cornelius, Nastair, Toby, Eric. Once again, and we have, of course, Bob. Welcome, Bob.
Hey, yeah, this is Dave's alter ego or something.
Hi, Bob.
Hi, Jeff. Nice to see you.
Yeah, likewise.
I have a question about the tetrahedron that Dave was proposing. It generally seems to me that the spheres involved with that are solid, uniform. They appear to be solid, okay, and uniform in mass, such that when they get pushed together, they form that tetrahedron. But on the other hand, if you had a point on each of those that were unique and stayed with it at that point, and when you initialize the particles and then let them come together, it would not always come, that those points would never always arrive at the same place unless your initial startup was the same. So what I'm trying to say is there's no orientation because of the physical size. They're round, they're uniform, but there's no reason that they actually come exactly together the same time, the same way each time, unless there's an imbalance in each of the particles. Now, it seems to me there's a good chance that the particles that are coming together are not perfectly balanced and uniform and round. Is there some way to put that into the blender? And for example, if they were more Bohr model oriented structures, and more flat, or more like a spiral galaxy, more because things are not balanced right. The model you have is perfectly balanced, and I guess I'm trying to bring imbalance into the picture.
Yeah. The answer is yes. I mean, you can do almost anything within Blender, and there's probably many examples far beyond what I have done. And again, I'm not even pretending to be a Blender expert. But some of the models, because you mentioned galaxies, and I want to reference Chris Seeley, who was the one that really kind of gave me a lot of the tips and guidance of how to build everything in Blender. He's done a lot of work with galaxies. Some of his work that he's done in Blender is quite amazing. And I can see if I can find links to that and share it with this group.
Yeah, so you have, he's done spiral, and they've found spherical galaxies, right?
I'm not sure if he's done both types, but he's certainly done at galaxy level. Yes.
Yeah, that would be interesting to see. But then I was bringing it down to a lower level because, but then regardless, if as long as they're spherical, balanced, they come to be a tetrahedron. That's quite amazing. But but all I'm saying is that perfect spheres, perfectly uniform, obviously tend to do that, which is kind of a interesting structural thing that sounds like would happen at many levels.
Yeah, yeah. You'll find. Franklin's already downloaded it. You'll find if you use either 3 or 4. 3 does a triangle. 4 does a three-dimensional tetrahedron, but they just form naturally. And there's nothing in there that is written into Blender that says you have to go here and be separated apart. It just happens. And that's kind of the fun part about it and seeing. But again, I want to emphasize that everything that was in here is I originally developed just for illustration to be able to communicate it, because there are still a lot of limitations. So I am not suggesting at all that this is complete and answering all the questions, but there are a lot of things in here, such as the formation automatically of tetrahedrons, that I just found to be amazing.
And do other shapes form?
I mean, other than the tetrahedron,
cubic,
3D.
obviously.
Yeah, most of them, there is a cube that forms in the particles module, but most of what are variants of tetrahedrons I found.
Okay, all right, thank you. Appreciate the presentation, very interesting.
Yeah, I think the concept of self-organization is an interesting one. So, if you put together, enough particles, like you said, probably if you put together 2 positive charges and 2 negative charges, it would probably just self-organize into a cube of just positive, negative, just naturally, right? So since it's, for example, my atomic model, I'm thinking that if I put enough charges into this Blender thing here, that it'll form spontaneously something like that.
Yeah.
I don't know if it'll will. I kind of have my doubts, but
yeah.
But
So,
if it did, that would be amazing, right? If it could self-organize into something, a specific geometric design that you don't necessarily program into in the beginning, right?
yeah. So can I use this opportunity then to talk a little bit about the contest, kind of following rules? But let's take a different path here. If someone wanted to download Blender and then they had another idea in mind to be able to create their own simulations outside of the contest, entirely possible. So what this does is it provides kind of that starting point to do, and then and this gets to be a little bit more advanced, but this is for you, Franklin, and for anyone else that might have gotten to the stage of downloading Blender. You'll find in Blender there's this tab called scripting, and then that's where you write Python scripts. So for example, you can use as a starting point nucleons, and you get the arrangement of positrons and electrons, or pick any module. It doesn't matter. And then what you can do is just write the Python scripting and change it. So I think to answer your question is, Franklin, you'll find you can do almost anything with it, and hopefully this provides a starting point for you.
Yeah, I think that let's see here. Yeah, exactly. I mean, that's a great starting point. I mean, I'm glad you brought this up, and like a lot of dissidents, you're not saying that, oh, I have all the explanations, because you don't. I don't think I do either, but certainly providing, a fairly significant prize, right? $2,500. I'm going to go after that one. I'm going to go try and simulate space-time the way I think it is, and show that, and at least try and prove to myself that how I think charges work can actually be simulated using only Newtonian mechanics, about things just crashing into each other. Because ultimately, the only reason why a positive charge should approach a negative charge is because it's being pushed. It's by collisions. It's the only thing that's available in Newtonian mechanics. I mean, really, there's no repelling ability at all in just Newtonian mechanics.
Yeah. So to your point, that's the reason why I wanted to get on this call. Is that's the main message I wanted to communicate. Right at the end of the day, that's about creating a project with an incentive that leaves it flexible enough that the end goal is just to solve this problem, and the problem can be solved multiple different ways. I'm not attached to everything you might see in my theory. I'm completely open to it being solved in different ways.
Now here's an interesting question.
Oh yeah, so the first answer to can hydrogen be displayed is yes. For that, you go to the atoms module, and then you insert one proton, one electron as the variables. And in fact, that's the default. Zeeman effect, no, that's not currently in here.
Yeah, it would be interesting to see whether you could, because that's a major thing that you kind of have to also explain, which is like how the spectrum is generated like that. I don't know whether, I mean, are you thinking about?
So the entire spectrum, so you see that everything kind of builds upon itself. I have ideas in mind for modules beyond molecules. So large bodies and gravity would be one. So you'll see that there's nothing in here on gravity. And one of the reasons is because it requires so many calculations. That's why this is kind of being built in stages, that you prove something first, and then you assume that that's proved because the computer just can't handle all those calculations. And gravity is one of those massive ones. So large bodies is one that I have in mind for maybe a phase 6 or 7, and the other one would be photons. In which case, then we have to explain the spectrum.
All right, here's another question here. One of my favorites, because I dislike toruses.
You know that the torus has not. So I agree that the torus actually has a huge part in it, and I think it's related to spin. But I can say so far in the simulations that the torus has not appeared. But I do believe that it will at some point.
I believe that it won't. That's just me, but because a torus is a very, very complex shape, and if you were to think, you know, what does it take to create one of these things? I mean, basically, we're talking smoke ring type complicated things in order to do that, and it's just not something that can easily happen. That particular shape, it's not self-stable. That's why I really don't.
Yeah, the only thing I can comment on is so far it has not appeared in just the things that just happen kind of randomly, you know, creation of these geometries. It has not appeared though. So that part I can confirm.
Okay, good, because I don't like toruses, right? But a lot of people like, say, base the electrons out of that as a very basic shape. You know, it seems to have a lot of traction with the dissident theories. You see them all the time, right? Yep. Toruses all over the place.
Yep.
Let's see here. What other questions we have in here? Something about time here. I'm not quite sure if I understand. I might have caught this comment in the middle of some other comment.
Time matrix. Well, I'm not sure if I understand this. Let me take a shot at answering this one. Blender has a 3D coordinate system. That's one of the nice things here for space-time. It can all be, you can find the position of anything in XYZ coordinates within Blender, and time is essentially the very bottom of Blender. There's it kind of walks through time. So between the three-dimensional coordinate system and the time scale, it's not even called time scale. I can't remember what they call it in Blender, but the very bottom, between those, you get your 4 coordinate system. I'm not sure if that's what he means as the components of time along the diagonal.
Well, I would think that one of the cool things about Blender is that it does allow you to have that time dimension.
Yeah. Because
you have the 3D world, but then you run it through time and see what happens to the particles over time. So that's kind of how I would interpret, say, time matrix.
Yeah, for the developers out there, you can use a Python call to get the position of anything in there. It's 3D coordinates and at any given time. So there's your 4 coordinates that you need.
Now let's see here. I'm looking for some more questions. Although I was looking at your website there, and I invite people to go just take a look at that, because it's not complicated. Not like a lot of dissident sites, you start reading it, and immediately you see stuff that looks like Greek, and it's like, yeah. So, but Jeff is very straightforward. So, I mean, one of the things that you base your entire theory off of is, say, the neutrino, right? So why the neutrino? Why not something else like, I don't know, neutron or proton or electron? Or, I mean, there's, or you didn't make up your own particle, I guess, is more significant, right? You used the neutrino.
Yeah, well, I'll answer this question because now we got down the path of theory, which I'm happy to come back to. Just as long as we've answered all the questions on the contest, because that was the main goal. But as long as you don't see any of those other questions on there, then I can help to answer that one. But I just want to make sure that that it accomplished the objective first, though. So
yeah, I think so. That's why we're kind of going, because I'm not seeing any specific question.
Then I'm happy to answer that one. So the neutrino, well, actually, I didn't really choose the neutrino at first as the model. Some of the initial work that I did, I was just trying to linearize all the different particle energies, from the accelerator. So put them into an equation, and then found one, roughly around 2 electron volts. And so that is around, depending on what you use as the energy, the rest energy of the neutrino. And so that's how the neutrino was chosen. And it just happens to be the smallest known particle out there anyway. So that's the short answer to your question of why the neutrino is the fundamental particle. There's more information.
You're not really married to it. It could still be either some mysterious particle, like Bob, you have the particle model, right?
It could be anything roughly around 2 electron volts. And I've got a very specific number that's on the website. But yeah, it could be anything around that range.
Sorry to butt in, but since I have control like Franklin does, I can just throw myself up there. I have a question about the physics behind the blender. Let me just start with empirical equations that were developed that are good, they're nice, they're handy to use, but not necessarily precise. If you use those in Blender and then set an experiment up, if you will, to generate something, you would expect to see the results that the empirical equations gave you in the first place, right? Isn't that part of the proof?
Yeah, so that's a good question. So first off, I'm not sure if a lot of people even have access to be able to change that in Blender. So earlier I mentioned Blender was just one path, and that I actually fully expect that the real solution would use a different program instead, because Blender has its limitations. But anyway, let's just say you have those equations, empirical equations in your words, and then you want to change it. Some of that has to be done at the core of the Blender application itself, and I couldn't even make those changes because everything is sort of programmed with a Newtonian physics engine within Blender. So I think yes is the answer to your question. It is possible if somebody had access to that in Blender. I don't, but I think it's more likely though that someone is going to program the ultimate solution using a program that just has a lot more flexibility.
Yeah. Well, my point is then, if you have another question, but let me finish this. If I have a model for which I develop a unique equation that's not empirical, and I expect that model to predict something that's different than expected in the empirical equations. Obviously, just said I probably will never be able to program my model in there. Especially, I'm not a programmer, but if it could be programmed in, I should be able to run it and see if that prediction comes true from the equations for a unique theory. You have a theory, you develop equations for it. It predicts something, and you want to show the prediction is true.
Yeah, absolutely. Yeah.
It seemed like that would be useful.
Yeah.
I'm afraid at my age I'll never get there, but
you have a son though that is a computer engineer.
Oh yeah, I could challenge him to do that, but he's got so many things on his plate.
He does.
I'm amazed he has time for anything.
Yeah.
But No, it would be a useful thing for anybody's theory. Whether it's Franklin's or yours, or if you have unique equations now, you want to get a visual, and if you can do it visually like that, all the talks I make, I gotta have a visual out there, a picture of something. It just is much easier to explain if you can do a three-dimensional visual of that.
Yeah, I think you hit the nail on the head, right? If you can explain things in equation format, then the proof could be a computer simulation. I mean, most of us don't have 10 billion to go and build our own particle accelerators to do this proof, and so the next best thing would be a computer simulation, and especially one where it's freely available, open source to developers around the world to help collaborate. And that's essentially what I've done. I've laid the kind of framework and the legalese to be able to do this so that anyone can contribute to it. And if you're a software developer, that means check in code to the open source repository. But hopefully also a financial incentive to do so as well. And I'm putting up, as I mentioned, for those that missed the beginning of this call, 15,000 of my own money, and I've already been approached by some people that are willing to contribute more as well. So I might increase that over time.
Okay, we got James here. James, go ahead.
Since we acknowledge that today we're talking about the simulator and illustration of the science as opposed to the science itself, as we established prior, I'm asking the question to my brother Jeff here. What is the objective of the contest? In other words, how would the judges determine which is the winning entry? What is the objective actually?
Yeah, so the objective, simply stated, of course, is I'll go back to being able to simulate with classical Newtonian physics, but that's still broad. So each of the different phases has specific requirements. So space-time, actually Franklin mentioned this earlier, one of the objectives of the very first module, space-time, is to be able to explain the interactions of particles. And the other one is the fundamental particle. And so that is listed out in detail on the project contest sites. There's rules for this. So as long as the rules are met, not just for what is being built, but there's also rules on how it has to be checked in, right? So for example, you have to grant access to the community for open source that somebody else can do it. Now the judges at the end will take all that into consideration and determine the winning entry. And right now there's 3 judges.
Thank you.
So will you declare a winner even if people just send in like 3 pieces of junk that don't work? I mean, or do you say no one solved this, and no one gets the prize?
Either way, I will award prize money, because it's unfair to ask people to do work and not do anything. So the money's allocated; it'll be spent no matter what. But of course, I would prefer that people hit the requirements, right? Because if you don't hit the requirements, then there's nothing to be reused in the next phase, and that kind of everything collapses in the future phases. But that being said, I also recognize that the first phase is maybe one of the most difficult ones.
Okay, so if someone sends in their Crayola drawing, that may not qualify, right?
Well, it technically wouldn't qualify, but if there were only 3 Crayola drawings at the end of this, I would still award a winner, because it would be unfair to ask everyone to contribute to a project and not have a winner at the end. But of course, the one that's going to be the winner is going to be the one that closest meets the requirements.
All right, people. So there's money to be had, right? Definitely. I mean, I think I've heard like contests like this, but the requirements to actually get the money are like obviously not reachable. But you're saying that if someone makes an honest effort, that someone's going to get it, even if no one really figures it out.
Yeah,
but,
well, this is hard, right? And it's physicists have been working on this for a century to be able to consolidate it. It's not an easy task. Hopefully we have things in bits and chunks that are manageable. If we need to extend the timeline, from 2 months to longer, maybe that's a consideration, as long as everyone agrees to it, in fairness to the developers that are working on it. But let me go back to your question, if someone were to get halfway there, and that's the,
No, I'd like
best
to just
entry.
add, like
Go ahead.
if the topic for today is the simulator and the context, I would ask again, what is the criteria for success or the objective of stage one, the space-time stage? Forget about all the rest of it, the very beginning. Because, for example, Franklin might be happy to know that when in a pool, or how is this different than a pool game where the cue ball goes down the table and breaks up the other billiard balls, and they scatter around, and they finally come to rest. I've never seen one of those games actually form larger assemblies of billiard balls. None of the games have this.
Yeah, to answer your...
And then if we're starting only from Newtonian, excuse me, just one more caveat, and then I'll be quiet. If you're starting only from Newtonian physics, how do you get? I don't recall in Newton's what is it, 3 laws of motion or force, anything about charge. So how do you get from how do you strike some billiard balls on a pool table, and suddenly some of them wind up having a property which we're going to call positive or negative charge?
Yeah, so to answer the first question about the rules, so the rules have been put, all the instructions have been put on a website, so there has been a lot of thought and detail to make sure that everything was listed.
Well, that's
so
very evasive, with all due respect. If you cannot state, if this is the subject for today, and you can't state what the objective is for step one, well,
I think you have stated the objective, which is to try and explain that, right? How can you get charge out of Newtonian mechanics? Maybe it can't be done, but that's the challenge, right?
Yeah, that's a challenge.
Right on,
there's certainly guidance on how to do that. But I just want to be clear, the instructions and the goals are clearly stated on there, such that if you're a developer, I mean, and all the legalese terms as well, so it's completely, I hate to use the word protected, but it's been thought through carefully about how to do judging so there's no, let's call it lawsuits later. So you'll find that the objectives and the rules are clearly stated. For that, I'm going to reference the website because it's long, right? It's not something you just put in one sentence. Let's see, your question though about charge starts to get into the theoretical part as well. I think you can get to, again, Frank, let me know if there's questions about the simulator, but James, I want to be respectful and answer your question. In the theory, but again, I want to make sure that this is completely open and flexible, that people could take a different track. But if we're talking about the theory, to get from Newton's laws of motion to be able to charge, you'll find on the website, and I can refer to a very specific URL, that charge is a function of displacement from equilibrium, which means its units are in the distance, so, SI units of meters. And so what that means for Newtonian physics is when balls collide, it would be that distance that it extends, but everything returns back to equilibrium, much like wave motion for air molecules, and those molecules return back to their original position in a wave.
So I see Cornelius. Yes, Cornelius has been waiting for a while. So go ahead, Cornelius, if you had some comments, unmute yourself.
Well, I've been backstage for a while, and part of it is I've brought up my computer, so I only have my phone to work with, and there's a lot of buttons that don't seem to be here, so I don't know how to wave. And I didn't see how to wave on the computer either, so they were saying wave
no
when
way
you
to
want to
wave.
join. Okay, so I didn't understand why they were saying wave if you want to join, because I've been backstage for an hour. I had questions, just time went on, but basically, Jeff, you're starting with the charge is trying to explain the charge fundamentally. Why are you working with the charge, which already seems like a complex force because it has polarity in that, rather than just what I consider a more fundamental force would be just gravity, because it only has one aspect to it, and that's attraction. Why do you consider something as complex as charge to be fundamental in the primary goal?
Yeah, so to be clear, I don't think that charge is fundamental at all. I think that was the question that James had asked. But I think your point is when you saw the section in later modules where it does have charge, where you have two oppositely charged particles that interact. The reason for that is really just comes down to how the computer simulation is built, that you have to prove it in an earlier phase and then just assume that it is a property later, because otherwise the calculations that it needs is far too numerous. You wouldn't be able to what I simulated would take way too long to be able to illustrate.
Okay,
But
and
I want to be
also,
clear, it's not fundamental.
okay, and also, well, you considered one of the fundamental particles to be the neutrino in your thinking, and I see the neutrino as only being visible or only being capable of moving at the speed of light, and it can't be held in position. I consider that would more of a wave characteristic, because I don't see how a particle, and I think you start with the wave theory where you have standing waves and traveling waves, correct?
Correct.
That's your theory.
Yeah.
And so the standing wave, I mean, the neutrino is basically a traveling wave. It doesn't stand still at any point, and so that's, again, I'm not sure why you're looking at the neutrino as being fundamental as opposed to something more like the neutron being fundamental.
Yeah, so as mentioned earlier, it's still left open for another particle to be the fundamental particle. In the theory, the reason why it came to be around the neutrino was just because of the rest energy that was calculated. For the purpose of the simulation, it's left completely open. Almost anything can be a fundamental particle.
Okay. Yeah, I was just looking at that. Has a more, it just basically has mass, and it has inertia, and it has gravitational characteristics. Those are less difficult to understand. The neutrino comes in three flavors to begin with. So which neutrino do you discuss? If it's fundamental, then why are there three different kinds of it too? So just a couple of thoughts.
Yeah, the electron neutrino, and I'll instead of taking a lot of time here, especially since we're kind of wrapping up with a few minutes left, you'll find that there's a page on neutrino on the website that discusses how the muon and how the tau neutrino are created, as well as other particles as well.
Okay, I'll look at those. Like I said, I consider the neutrino just to be a temporary thing. It can only exist when it's moving at the speed of light. So yeah. A lot of like the other particles that come out of the collision of a neutron, they are not necessarily there, but when you collide them, they attain spin, and when you've got spin, then you've got these other, then you get charged. But I'll look at your site some more, and maybe we discuss more utility. I did have a question about Laurie Grenier's input, and I think she deals with waves a lot too. Is that correct when you spoke to her?
Correct, yes.
Okay. I'll let it go, because we're obviously very late in the conference, and I didn't get in earlier. So
yeah, sorry, but
thank
I
you.
appreciate the question.
Yeah, thank you.
Okay, so we're at the end here. So I'm just going to let you summarize there, Jeff. Okay, why don't you summarize your contest and any closing comments?
Yeah, so if I were to quickly summarize to our discussion, it would be that I hope to find software engineers that share the same objective, to be able to prove what we've stated earlier as a lot of the behaviors of particles and their motion with classical Newtonian physics. And so the structure of a project has been created such that developers from around the world can collaborate. Hopefully there's the financial incentive as well. And my role in this is really just to help move things along. I don't pretend to have all the answers, but I would love to see the answer one day.
All right. Well, thank you very much, Jeff. It's been a fascinating presentation. Thank you for going through the trouble of putting together this contest. It has real money backing it up. So I hope that people watching this will be inspired. I mean, it's not hard to load this stuff. I mean, just while Jeff was speaking, I loaded Blender and I loaded the add-on and I ran it, and I could start seeing what it does. I don't know whether I'm going to learn Python so I can plug in my own theories, but hey, it's worth a shot, right? So, but that will do it for this week. And
Well, let
I'm
me
not sure
just
what we're
break
having
in,
next week. We'll have.
No, wait,
Jeff,
sorry, Bob was trying to say
Franklin,
something.
break in just on behalf of David.
Yes, go ahead.
We invited Jeff to be here. I appreciate your efforts, Jeff. Thank you, Franklin, for helping a novice out. I learned a little bit just watching here how to control this. So anyway, Jeff, thank you, and we hope to see you again.
Yeah, thanks, Bob. Thanks, Franklin. See you guys.
All right, bye.
Bye.